Alright, so we start the class on matrices. First, we would like to look at notations which are very important as far as our understanding of the subjects are concerned, and this is true of mathematics as such. So, for us, if I write n for the set of natural numbers, so n is going to look like, so it has elements of the type 1, 2, 3 and so on, and we call it the set of natural numbers. The set of natural numbers. Similarly, we have the set of integers which have entries 0, 1, -1, 2, -2, 3, -3 and so on. So, we write it as the set of integers. Similarly, we have the rational numbers q, which is of the type p upon q. P and q are integers and q is not equal to 0. So, this is called the set of rational numbers. Rational numbers. Then we have what are called real numbers. C for the set of complex numbers. So, what we know is that if I look at set of natural numbers, then we can add. So, if I look at the set of natural numbers, we can add two natural numbers, but we cannot subtract two natural numbers. For example, 2 minus 3 does not make sense in the set of natural numbers, but it does make sense in the set of integers. Fine. Similarly, if I want to write 2 minus 2, again 0 comes, which is not an element of natural numbers, again it is an element of integers. So, in the set of natural numbers you can just add, in the set of integers we can add and subtract. When we want to multiply natural numbers, two natural numbers can be multiplied, you are still inside that set. Similarly, set of integers you can multiply, you are still inside that set. But when you want to divide, we have problems with natural numbers as well as integers. So, we go to what are called rational numbers, real numbers and complex numbers. So, if I look at these three sets, rational numbers, real numbers and the complex numbers, they have a very nice property that we can add two numbers. So, we can do add two numbers, we can subtract two numbers, multiply two numbers and divide by a non-zero element. So, what is the non-zero element in all these three sets? So, in all these three sets, 0 is the 0 element. So, I can divide by every number other than 0, and that is a meaningful object. Fine. So, these three sets which have the property that we can add, subtract, multiply and divide by a non-zero element, they are called fields. So, in mathematics, anywhere these things happen, we call it as fields, and we will write it generally as f here. So, if you see all the notations, what we have done is that we have integers, natural numbers, rationals, real, complex, f, everything has an extra vertical line to indicate that they are sets, and we will be following that notation throughout. We also have sets of the type q of root 2, which are of the type a plus b root 2, and a and b are rational numbers. They are also fields. We had seen in our school days that there was a notion of So, for example, so let me use the word, I do not know whether you remember it now, rationalization. That is, we want to make them rational. So, denominator is to be made as a rational number. So, for example, if I want to write 1 upon 1 plus root 2, I can multiply this by 1 minus root 2 by 1 minus root 2, and therefore, I will get it as 1 minus root 2 divided by 1 minus 2, which is root 2 minus 1. So, the denominator here, so in the denominator, there are no irrationals. So, here the irrational is root 2. So, in the denominator there is no irrational at the last step, all right. So, we will be looking at such fields. We also have fields what, so if you look at all the fields that we have seen till now, they have the property that they have infinite number of elements, but we also have fields which have finite number of elements, and it turns out that for every prime p there is a field corresponding to that. So, for example, let us look at Z5. So, 5 is a prime, 5 is a prime. So, what is a prime number? A number which is divisible by only 1 or itself. So, 5 is a prime number. So, if you want to look at Z5, what I will do is that its elements are going to look like 0, 1, 2, 3 and 4. The addition here is going to look like, so if I want to add 0, which says 0, 1, 2, 3 and 4, all right. So, there is, I should have written it slightly differently. So, addition of 0 with 0 will be 0, 1, 2, 3 and 4. With respect to 1, if I want to add, then it is going to be 1, 2, 3, 4. But now note that 1 plus 4, that we have 1 plus 4 is supposed to be 5 as far as natural numbers are concerned, but 5 is not an element of 5, does not belong to Z5. So, what we do is that we divide this number which is bigger than 5 by 5. So, we look at the remainder when 1 plus 4 is divided by 5. So, the remainder is 0 here. So, therefore, the table here will be 0. So, 1 plus 4 is 0. Similarly, if I want to look at addition with respect to 2, 2 plus 0 will be 2, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, which is again 0, 2 plus 4 is 6, which is same as 1. So, 1 is the remainder, 1 is the remainder, when 6 is divided by 5. Similarly, you can complete this table for yourself. I would like you to do it yourself, try that out. So, this is as far as the addition is concerned. As we said, we want this to be a field. So, for a field, I need that there should be a multiplication also. So, let us multiply it. Again, let us make a multiplication table for us. So, I have the numbers 0, 1, 2, 3, 4. I also have 0, 1, 2, 3, 4. I already know that 0 times any number is 0. So, I do not have to worry. 1 times any number is also the same number. So, it will be 0 here, 1 here, 2, 3, 4. So, fill this yourself, fill it. Similarly, I would like you to fill this part also. Fine. Let us multiply by 3 and see what the table should be. So, 3 times 1 is 3 and 3 is in the set. So, 3 remains as it is, but 3 times 2 is 6, which is not in the table. So, we have to divide by 5, and if I divide by 5, the remainder is going to be 1. So, as in the case of addition also, 6 look like 1 itself. 3 into 3, if I look at, is 9. Again, 9 is not an element of the set Z5. So, I have to divide by 5 and the remainder is 4 here. So, I write 4 here. 3 into 4 will be 12, and which is nothing but 2 when I divide by 5. So, this is what I am going to get. I would like you to complete this table also. So, what I would like you to observe here, that I have a number 1 here. So, what we are saying is that 3 into 2 is 1. So, what we are saying is that 2 behaves as the reciprocal of 3, in the sense that if you remember, 3 into 1 upon 3 was 1. Similarly, here 3 into 2 is 1, and there we are also 1 upon 3 into 3 was 1. Similarly, 2 into 3 is 1 here. So, 1 works as the reciprocal identity element of the set. So, 1 is always the identity element of the set. So, Z5 is a field, because we can add. Similarly, if I want to subtract, then what will be minus 3. So, 2 minus 3, if I want to look at what is 2 minus 3 here. So, 2 minus 3 will be 2, and I can replace minus 3 by, or just write. So, what should I say? So, you can write 3 as, yes, anything that you can think of. I can write 3 as minus 2 itself, because 3 plus 2 is 5. So, let us look at the table. 3 plus 2 is 5. This is the table that we have. So, from here we see that 3 plus 2 is 5. So, I can replace 3 by minus 2 itself, because 3 minus minus 2 is 5. So, I can replace 3 by minus 2, that is, it is the additive inverse. So, therefore, this is nothing but 4. So, is that okay? So, understand again, 3 minus 2 is 1, and 2 minus 3. So, 2 minus 3 as such is supposed to be minus 1, but minus 1 is also same as 4, because minus 1 plus 5 is 4, or when I divide minus 1 by 5, the remainder is 4. Is that okay? So, for every prime p, we have a field Zp, and sometimes we may like to look at things there also, if at all, but I am not sure when I will be able to, depending on the syllabus that I can cover. But we have to study things over these fields also. So, whenever we study things, I will be writing f in place of rational numbers, real numbers, complex numbers, or any field of this type which has finite number of elements. Fine. So, now let us go back to what we are supposed to do. We are supposed to study matrices. So, this is as far as the notations are concerned. So, now let us go back to the actual syllabus for us. So, we look at what are called matrices. So, what is a matrix? So, matrix is, we generally write it as A, B, C, D, we will be writing it as capital, and it is nothing but an array. So, it is just an array. Generally, we say it is a rectangular array. Of numbers. So, this is the way we write. We just say it is any matrix A is an array, rectangular array. A rectangle could be a square also. So, it is just an array of numbers, and the entries of this could be any of the numbers, or it could be functions, it could be anything. Depending on the requirement, we will change our ideas, but for the time being our entries are going to be mostly real numbers. Once in a while I look at complex numbers as entries, but mostly it will be real numbers for us. So, for example, we write it as, so the matrix, so if this array or this matrix is of size m cross n or order, so or the order of this matrix is m cross n, then the entries of this matrix generally written as A, so a small a corresponding to that, A11, A12, and A n is there, so it is A1n, A21, A22, A2n, AM1, AM2, AMN. So, the entries of this matrix as I said, they are of the type, so we generally write A as Aij. Sometimes we write like this, sometimes we will write it as Aij. So, depending on the situation, these brackets can change, but the idea is that Aij here or here, it means that I am looking at an entry which is at the intersection of ith row and jth column. So, the first thing that we need to understand is that what is a row and what is a column. So, row corresponds to what are called the horizontal arrays, and the columns, they correspond to vertical arrays. Fine. So, for example, if I want to write the first row, so this is the corresponding to the row, and we are looking at the first row. So, this corresponds to the entry A11, A12, A13 till A1n. Similarly, if I want to look at the second column, the entries are going to look like A12, A22 till AM2. So, as I said, the rows are nothing but horizontal and these are vertical. Sometimes we also write Aij as A of ij or maybe A of ij or as A of ij, depending on different situations, our entries are going to be to look like this. All right. So, this is as per as our notations are concerned about the matrices. We will come back to them again. So, remind yourself that a matrix A has what are called m rows. Here so first row is A11, A12, A1n, second row till m rows. So, m, the first here corresponds to the rows and n corresponds to the columns. So, number of rows and number of columns that we are looking at. Fine. So, it is an array consisting of rows and columns. Aij corresponds to the entry in the intersection of ith row and jth column. When I write A1 and with a colon, it means that I am looking at that row. So, A3 comma colon means the third row. Similarly, colon comma a number means I am looking at that corresponding column. Fine. So, now let us look at an example and why do we need to understand these matrices. So, example. So, we are going to solve a system of linear equation here. We have already done in our school. So, let us look at the system again. So, we are going to solve 2x plus 5y equal to 7 and 2x plus 4y is equal to 6. So, what we do is when we solve this system, we just, since it looks very simple, what we will do is that we will just subtract it. All right. So, write it back, minus minus minus, what we get is y is equal to 1. Now, putting it back, what we will get is that 2x is equal to 7 minus 5y, which is nothing but 7 minus 5 times 1, which is 7 minus 5, which is 2. All right. And therefore, what we get is x is also 1. So, the solution that we have here is solution x is 1, y is 1. In some sense, we are saying that 2 times 1 plus 5 times 1 is 7 and 2 times 1 plus 4 times 1 is 6, and therefore, both the equations are being satisfied. What we would like you to understand further after these lectures is that this vector, so there is a vector in R2 that we are looking at 2 2, this corresponds to the variable x. So, you have the variable x in the above equations, and this the vector 2 comma 2 is associated with x. All right, so we write it as it is. Similarly, the vector 5 comma 4 is associated with the vector y. Y is again a variable unknown. And what we are looking at is that this vector is this equal to this. So, we are, can I say that what we are looking at is that, so question, can we rephrase the above system as, can we find x and y such that certain multiples of 2 2 and 5 4 can be used to obtain the vector 7 comma 6. So, this is the question that I am asking. Can I find some multiples of 2 2 and 5 4? When we add it, we do get back the vector 7 6. So, here if you look at, our solution was, as far as we are solving the system of equations, the solution was x was 1, y was 1. So, here if I look at 2 2 times 1 plus 5 4 times 1, because y was also 1, is nothing but 2 2 plus 5 4, which is nothing but 7 6. So, we see that we do get back what we were asked for, that yes, there is a solution for x and y here, and this is nothing but our vector addition, where we are adding the vectors, that we have a vector here which is 2 comma 2, and I have a vector 5 comma 4. So, I have a vector here which is say 5 comma 4. So, it will be somewhere here. So, this is the vector 5 comma 4. Then we are saying that we can add these two vectors here and get the vector 7 comma 6. What is called the vector addition. So, this is the vector addition that we had learnt in our school. So, we are looking at vector addition. So, I would like you to understand this once more, that when we are solving a system of equation, we are not just solving a system of equation, we are also looking at what is called vector addition. So, we are just multiplying vectors by certain size to deflate their size or reduce their size, and then add them. Now, does this also make sense as far as questions in 3 dimensions are concerned, vectors in 3 dimensions are concerned? So, let us look at another example, example 2, where we are looking at x plus 5y plus 4z is equal to 11, x plus 6y minus 7z is 1, and the third equation is just we add it up, 2x plus 11y minus 3z is equal to 12. So, if you see this system, all right, the third equation is nothing but sum of the first two equations. So, therefore, the third equation is redundant for us, and therefore, what we understand is that the first equation is a plane, second equation is also a plane, and you can see that they are not parallel, and therefore, they intersect in a line. So, we have infinite number of solutions for this system. I would like you to verify that the solution here is nothing but 61 minus 59k, y is minus 10 plus 11k, and z is equal to k, with k arbitrary. all right. So, I am not solving it, I had done it myself earlier. So, all right. So, we need to understand that this we have already solved. So, let us try to understand what do we mean by this solution here. The solution here means that if you plug in the values of x, y and z, you do get back the equation. I would like you to understand, which is very important here, is that look at the vectors corresponding to the variables x, y and z. So, corresponding to x you have the variable 1, 1, 2, corresponding to y you have the variable 5, 6, 11, corresponding to z you have the variable 4, minus 7, minus 3. And what we are saying here is that if I multiply this vector by 61 minus 59k, this vector by minus 10 plus 11k, and this vector by k, and then add them up, what we are going to get is 11, 1, 12. For example, all right, if I take k to be 1, so k equal to 1 will give me 1, 1, 2 times 2 plus minus 1 times 5, 6, 11 plus 4 minus 7 minus 3 is equal to 5 plus 4 is 9, 4 plus 2 is 6, 6 minus 5 is 1. Have I done some mistake here? K is 1, so k is 1, oh sorry, it should be plus 1 here. So, all right. So, k is 1 here also, 5 plus 4 is 9, 9 plus 2 is 11, minus 7 and 6 plus 2 is 8, and this minus 7 will give you 1, minus 3, and then 11 plus 4 is 15, 15 minus 3 is 12. So, you can see that we do have vector addition again, which is coming into play here, fine. And the important thing to note is that if I replace this 12 by say 13, then the third equation that we are going to get here is 2x plus 11y minus 3z is equal to 13, and if I subtract this equation from the first two equation, I will get 0 times x plus 0 times y plus 0 times z as 1, which has no solution. So, I would again like you to understand here that this will again tell me that if I am looking at the vectors 1, 1, 2, 5, 6, 11 and 4, minus 7, minus 3, then I cannot write. So, the vector, so if I look at this vector, so let me look at the place. So, if I look at the vector say 11, then 11, 1, 13 cannot be written as sum or multiple of things like vectors of this type, fine. So, I will end the lecture here itself, and in the next class we will again come back to these equations. Thank you.